Hello, everybody. So this is part two of the start to data visualization. So hopefully if you're watching this, you've already watched Liza's video, data visualization part one. We're working in the tidyverse, specifically ggplot, and Liza already showed you how to do scatter plots and scatter plots and box plots. So what we're adding in this video are two additional steps, one time series type plots, which ultimately we're going to use the same functionality as for scatter plots and box plots, but just in a slightly different way. Then we're going to talk about faceting, which if you don't know what that is, you're in the right place. And then finally conclude with a quick chat about ggplot themes. So to get started, let's go ahead and load the tidyverse. And then we are going to load the portal_data_joined.csv file. And in this case, the code in this course material module uses the filter function and the complete cases function. So again, what that's doing is just sort of getting rid of any cases where we have an NA somewhere in the observation. Doesn't matter, we're just practicing plots in this case. All right, so what that generates is a data frame or a tibble that has about 34,000 rows, 13 columns for different variables, and we're going to call that object surveys_complete. Okay, so simple time series here will work with years. If you view the surveys complete or read off the different columns, what you can learn is that there's a whole bunch of different variables, one of which is the actual time, the month, day, and year that the sample is collected. So we might, for instance, want to do a simple visual, and this is, again, you can find this code in the course material module 4 data visualization part 1, where we're counting up the number of species IDs by year. And so what this code would be is it simply takes the survey as complete object, pipes in the count function, and it's saying count species ID and year. If you run that new object, you end up with the count of each species ID and year. So I don't know what DM stands for, but in 1977, there was 181 of whatever the DMs are. Let's just call those squirrels. All right, so we can open up ggplot, and in this case, so we'll just call ggplot open and close parentheses, and then we'll set the data equals yearly counts. You can actually just run that and nothing happens. It should open up a blank plot window on your screen. Here, I'm going to pull over the plot window so that shows up. So there's all sorts of things. You practice with Liza, for instance, you could turn this into a scatter plot. In our case, we want to plot the count of each species year to year so you can view change over time. So I think it's fairly typical for time to be on the x-axis instead of the y-axis. You could use a function you're already familiar, I guess like a ggplot add-on function you're already familiar with, like geomePoint. Within the aesthetic setting within geomePoint, or the mapping setting, you could say x equals year, y equals n. If you run that, you're going to get a scatter plot where there's a point for each species count per year. This isn't necessarily what you want, but you can see we have the building blocks here that for creating that time series plot. In this case, you can just see the numbers, but you can't actually tell like what species have gone up and down over time. So first thing we might change is we might say geom path. Now we have a squiggly line, and I think this looks a lot like what is shown in the course materials module page. Not very helpful either. What's happening here? Well, so as far as R is concerned, all we did is we fed in a data table that had years and species and count. But you'll notice in this code, we didn't actually specify anything about species. So what R did is it went row by row and it said, what's the year? That's the X coordinate. What's the count or the N? That's the Y coordinate. And it simply drew line to line, like tracing the dots from each combination. So it's going up and down and up and down. We get the straight lines because it's tracing through a bunch of observations that have the same X coordinate for year and different Y coordinates. Clearly not quite what we want. All right, so let's start editing that. One thing you can do is you can set group within the mapping or the aesthetic function. In this case, group is species ID. And all that does is that tells R that when you are creating a path in this ggplot, there should be a unique path for each unique species ID value. Actually going to copy that. I'm going to paste it, and I'm going to delete the group. So that way I'm not overwriting the code I already did. So we started with that simple code that was wrong. Now we've added in the group function. Okay, this looks a lot better. So we have different lines shooting up and down. From here, you're basically all the way home. We can start to add in certain fun features. So I'm going to copy that call again, make some notes here. Add color. So let's say you wanted to have a different color by species. You could say color equals species ID. This won't affect the grouping because it's the group setting that determines how the actual like physical plot looks or the virtual plot looks. But if we call color on species ID, R is going to give each line a different color. So in this case, because there's so many species, this isn't necessarily helpful. You can see that there are like 6 or 7 different shades of pink, for instance. In general, R sort of does the best job it can of like spacing out a color palette. At later date, we will also show off all sorts of nice color palettes that people have designed, like the colorblind palette and the Viridis palette and the color brewer palette, but these don't necessarily solve this problem. I think even like the Tableau themes usually max out at like 20 different colors, and so this is a little more than R is equipped to deal with. From here, there's also a lot of customization you can do. For instance, you can shift where the label is, you can edit the labels, you can modify those color palettes. One feature I do want to highlight is, let's say you wanted to have points on that path. And so you wanted that path, but you wanted each yearly observation to have a point just for aesthetic purposes. The easiest thing to do is actually to move your mapping call into the initial ggplot call. And what that does is that sets the same mappings for every geom you call within ggplot. So now we're saying whether we call path or box plot or points after this, the x-axis is year, the y-axis is n, that sort of thing. You don't always want to do that, but in this case, that would let us say geom path, geom point. And if you run that, the colors are the same for the points in the path. You get the dots and the lines without having to specify it. This understandably doesn't look that good, but again, just kind of showing what you can go from there. Okay, so now with faceting, and faceting is not specifically a time series thing, but it is something that's often very useful in time series. So I'm actually going to find the case where we had individual groups, but no color. So just to refresh your memory, here we just have all the different black lines for species, but you don't know what species is which. Now ggplot has a function called facet wrap. And what facet wrap does is it says we want to essentially like expand this plot to create like a unique grid or like a unique panel for each type of observation that you care about. So in this case, we're going to open a function, or sorry, not open, I guess open a formula. I'm stumbling over my words a bit this morning. So we're going to make a one-sided formula with nothing on the left side. And then you're going to make the tilde, so like the middle of the formula, and type something like species ID. So let's say we want a different time series panel for each species. Oh, it's giving me an error because I specified the group as well. Or a warning, it's not necessarily a problem. It'll work either way in this case, but let's just go ahead and remove it for simplicity. And what results here is you have a different panel for each species ID. And then what each panel plots is the particular count and time series for each of those different animals. So this shows a couple things. One, super flexible, right? You can blow it out in all sorts of different directions, but also it's not necessarily that helpful because the count of some species is much higher than others. There's a lot of plots where you can't see much. So there's some hidden functionality. If you type inside the facet wrap function, you can see things like scales, for instance. And what scales does is it determines whether every panel in the grid has the exact same scale or not. So in this case, let's say we wanted to keep the same X scale, so the same time series, but we wanted to let the Y scale vary by different species because we're not interested in the raw count, we're interested in the trajectory. So you can see, or you can read in the help file, there's 4 options for scales. There's fixed, which is everything the same. There's free, which is the X and Y axis customized based upon the particular data subset, or there's free underscore X or free underscore Y. In this case, we just want Y to move, so we're going to say scales equals free underscore Y. Getting that same warning still. Okay, and so in this case, now you can see that you actually get a lot more trajectory because the y-axis changes pretty markedly between the different plots. A couple other things to note about facet wrap. One, you can test what happens if you put it on the left-hand side, species ID on the left-hand side of the formula instead of the right hand. In this case, it doesn't work. So what is up with that formula? Well, actually, that formula allows you to specify two-way grids. So you could imagine a case where each panel is a particular combination of 2 different factors. I don't think that would necessarily be useful in this case. I think R is going to flip out here. Yeah, so my computer's angry because I said make a different panel for each year and each species, which is sort of nonsensical, right? It's just going to be a dot, but just to show like that is actually something that is tolerable. Another thing to note is there's a separate function called facet grid. I got to stop. My computer is frozen. There we go. And if you look at the help file for facet grid, oh, my computer's still frozen. Let's close out all these plots. So facet wrap, and this is essentially what the help file walks through, is facet grid is the case when you want to be really specific and you do have like that X and Y combination. Facet wrap is typically what you do when there's only one variable you want to blow out panels for. And so facet grid is going to be your best bet if you have some sort of like X, Y or like multi-factor combination you want to generate. It also allows you to specify the number of rows and the number of columns. Facet wrap does as well. To show you an example of that, we can call facet grid. We'll make that one-sided formula, species ID. Okay, so that plot is going to show up. And in this case, that was actually 1 row instead of 1 column, but we could instead say number of columns 4. Oh, didn't like that. What am I doing wrong here? Oh, just calls 4. Let's go to facet wrap. I don't think it likes because I only have the one-sided, so grid I think might be exclusive there. And call 4. There we go. So now you can see you can start to toggle sort of the actual layout. And so this is 4 columns. If we instead set it to 3, that shape's going to change a little bit. 3 columns, much more compression along the y-axis. Okay, that's all fairly straightforward. I think the best way to think about this is you can learn sort of 80% of what you need doing this, like practicing the time series stuff and the facet wraps fairly quickly. That last 20% about like getting colors to look well when you have a lot of groups, about getting scales right, about getting the legend where you want it, about figuring out sort of how to make facet grid work when you have multiple factors, which I'm not going to wade into just for the sake of time in this video. That stuff tends to take a little more high touch. Generally, I think it's the case that you can make your first ggplot for your paper or whatever fairly quickly, and then you spend a bit of time like making it actually look like a high quality professional figure. Which brings us to themes. So one thing I want to highlight about the theme. So if you go to the course materials, you end up with after we talk about faceting, it talks about the challenge. You do the challenge, then under that there's a section called themes. So themes are sort of like a completely optional feature, but they allow you to quickly sort of adjust multiple things about a plot at once. So what themes are is a set of code that has like essentially like an object that's already encoded a bunch of plot aesthetics altogether. And so I'll show you one, and I think that'll help clarify it rather than me explaining it first. So I'm going to type a plus sign to add to this grob, and then I'm going to type theme. And if I start typing theme, a bunch of ggplot options show up. One of my favorites is theme_BW, which is simply theme black and white. And so if you were to view the help file for theme_BW, it would show you all these different plot settings. And essentially those are just like different settings than the base ggplot. If you run that, as you might predict, now we end up with this black and white under setting. So it's not that like the colors are gone that you specified for the different species, but underneath we don't have that sort of like classic gray R plot background that you can see in the base plot. Instead, we have that white bottom and then the black grid lines. I would always recommend, at the very least, when you make a plot, do like some very simple theme toggle like this. It just sort of sets it apart and makes it seem less like something you did in like your first R class and more like, hey, you put a little bit of time to that. And see, it took almost no effort. Lots of different themes. Theme dark, it's going to give you like sort of a black background. The other thing to remember is if you like a particular theme, but you don't like something specific about that theme, you can, after calling the specific theme, call a generic theme object and actually change a setting. So let's say we wanted to, just to try something, let's make the text really big. And go ahead and ignore the actual mechanics of this for now. I just want to sort of show you that it's possible and we can follow up how to actually go about doing this. So I'll just set the text size to really, really large. And now if I run that plot, all the text is much bigger. So you can call a theme and then make micro adjustments to it, which is really helpful. There's also some fun themes that you can access if you install the GG themes package. I already have, so I'm going to go ahead and load it. So the GG themes package has useful themes for maps, for instance. It also has some fun features like, let's say you wanted it to look like a graph in The Economist, or you wanted it to look like a Stata graph. You can call the Stata theme and it ends up looking like you produced it in Stata. So a little bit of goofing around, but I think it can be fun to play with. Okay, so I think that's about it for this video. So we talked about time series, which again is fundamentally just a scatter plot that you're drawing lines through. So the trick is making sure you get the grouping variable correct. So you're drawing the lines between the points you want. We talked about faceting using the facet wrap and the facet grid function. So facet wrap is when you have one variable you want to have unique for each panel. And so you call a one-sided formula with that variable on the right-hand side of the tilde. And then ggplot, when you call it, will make a separate panel for each factor or each character value. Facet grid is when you have two combinations, and so you want each panel to be a sort of a double combination of two unique factor or character values. And then we talked about themes, which are sort of high-level ways to adjust some of the macro default settings in your plot. All right, thank you, and let us know if you have any questions.